Hello everybody and welcome to another video. In today's video I will be taking a look at the new CR10V3 printer which came out recently. This is the follow-up video from the initial unboxing experience, so if you're curious about what it looks like to put the machine together, make sure to check out the video in the description below. Now, full disclaimer before we begin, I purchased this machine with my own money and was not paid to do this video, so everything you see here will be my own opinion. To start things off, this machine is a large printer which prints a dimension of 300 by 300 by 400 millimeters and can reach hotbed temperatures of up to 100 degrees Celsius with a printer nozzle temperature of up to 250 degrees Celsius. Unlike many 3D printers, this machine uses a direct extruder which pushes the filament directly into the nozzle instead of the traditional Bowden tube. This feature makes it quite suitable for printing flexible filaments, which is what was tested in this machine. Also included with this machine is a runout filament sensor, which is located on the top of the machine along with a spool holder. If you're getting this machine yourself, you want to keep the spool holder height in mind since it does take up more room because of its current location. This is, however, useful if you're more limited in your overall space since you can easily place this on a table which doesn't have any fixtures above it. I personally did end up liking the fact that the control box was separate since this allowed me more options in placing the machine. I, for instance, placed the 3D printer sideways but oriented the box controls towards the front of the table so it would have easier access. Having a control box separate also makes repairs a good deal easier since you can completely disconnect the machine in order to do proper maintenance without having to deal with the whole unit. The hotbed itself has a very unique design in that it is easily removable, which makes replacement easier in the future. And I do wish more companies designed their print beds in a similar manner for this reason. The design also makes it possible to upgrade the print bed in the future with a flex plate, which is great news for those who enjoy tinkering with their machines. The print bed is also pre-insulated to help maintain the heating temperature and is a welcome improvement to what can be typically seen in most printers today. I did see some reports about the V2 having issues maintaining its heat, however this isn't something which I found to be an issue in the model that I currently have. While having a touchscreen is more visually appealing and less daunting to those who are new to 3D printing, it is still fairly easy to navigate. The machine does come with basic instructions, which do help significantly in this area. There are some things which you may wish to know since they can often be taken for granted. For instance, if your filament sensor goes off because there's no more filament available, it goes on standby. In this case, the nozzle will cool down, which is a good thing for safety reasons. However, it will mean that you need to reheat the nozzle prior to changing the filament. This is something that can be easily done by going to Prepare plus Preheat PLA, Preheat Nozzle. This will only preheat the nozzle, at which point you can remove the filament in question. Be careful not to jostle the nozzle, otherwise your print will shift and this could cause layers to be more brittle when they come apart. Now, although the direct extruder is great for working with flexible filaments, you definitely want to be aware that it can be difficult to maintain. The way it's assembled, the wires get pinched very tightly to the side of the housing, which does keep them out of the way. However, it can make reassembly interesting to deal with. Nozzle replacement shouldn't be too affected, however. Just keep in mind that you'll want to raise the print head before you do so. Creality has a very good tutorial on their YouTube channel which talks you through the steps, and I recommend that you look at that video for more details. Most blockages can be removed with the aid of provided tweezers, so keep those nearby should you need them. For more severe blockages, you will most likely need to use the included needle to help push the blockage up and out, but in most cases it can be removed by doing a cold pull. From a complete cool down state, start heating the nozzle up to temperature while pulling the filament. This causes any deposits to be lifted up with the filament, since these become hot enough to stick to the filament being pulled out. This may have to be repeated 2 to 3 times, but does a much more thorough cleaning of the nozzle. One thing to keep in mind is that the extruder does have a Bowden tube placed in the heatsink, so on occasion you may need to replace this. However, that should be rare. The nozzle does ship with a standard 0.4 nozzle along with its replacements. However, I would suggest that you replace this with a 0.6 or a 0.8 since this would reduce your print size significantly for larger prints. If you require more detailed pieces and are willing to wait significantly longer, then it may still be worthwhile. When it comes time to removing the filament, you'll want to push this portion forward until the filament comes out. Make sure the nozzle is heated before you do this, otherwise it will be far more difficult to achieve and could result in the filament snapping within. The filament runout detector currently only accepts 1.75 filament, which isn't surprising since the filament trajectory could be problematic when the print head comes too close to its maximum height. I've had some issues with the filament snapping since it doesn't have a Bowden tube to help guide its trajectory. Fortunately, this was mostly an issue with the cheaper filaments, which were more brittle. However, part of this could be caused by the extremely tight filament sensor. The filament sensor produces a lot of friction, which may be the source of this issue, and I would like to see this addressed in the future. When the filament snaps, it doesn't trigger the runout sensor because of its current location. This is far less pronounced when printing with TPU, but was aggravated when using soft PLA. Having the sensor away from the print head is still very much appreciated since it makes filament removal easier. However, I would like to see the angle of the spool revised along with the runout sensor. Having a gradual entryway for the filament sensor would get rid of the harsh edges which seem to be causing the friction and would be a minor fix in the future. The frame is very well supported given its size. I've experienced very little Z-wobble, which is very much appreciated. With the wiring, some areas have been glued to help ensure the connection points don't become loose over time, which is good call since I've definitely experienced this issue with other machines in the past. The only thing to keep in mind is that this will make it more difficult to replace such wires in the future because of how they're currently attached. However, if they last much longer than this, it shouldn't be an issue. All the cables are clearly labeled, so tracing connections are a lot easier and makes future modifications easier to achieve. Along with the sturdy frame, the machine has silent stepper drivers and a pre-built MOSFET. Although I personally prefer when the MOSFET is separated from the board because it's easier to replace, I can appreciate the fact that it's one less item to troubleshoot in the future. So how did this machine perform? Well, let's start with the default test prints that came with the machine. These prints are always a good way to make sure that your machine is functioning correctly and should always be the first thing that's printed. So in my case, I chose the dog, although it's difficult to see just how well it printed because of the filament color that came with the machine. I tried printing the flexible PLA, which I soon discovered had a tendency to get stuck because it shaves so easily within the gear system. The results, however, were very comparable to the dog. With that out of the way, I immediately changed to a 0.8 nozzle to see just how well it could print with a wide variety of materials. Once again, I printed the flexible PLA as well as some regular PLA and TPU filament. Here were the results of the standard benchy test. I then followed this print with a large scale print for my client in TPU, which for NDA reasons I can't show on video. I can say that the 4-day print was comparable in quality to my small benchy test in TPU. I also 3D printed a bust of my own sculptures. To test the full build volume, I then printed a vase in vase mode. This machine is really good, especially if you already know that you want to print in flexible filaments. While the user interface is probably not as modern, it does the job quite fine, and with a couple of tweaks this could be an even greater machine. So would I recommend this machine? It's a good machine if you already have some basic experience. I probably wouldn't recommend it if it's your first printer because of the user interface, and most users don't require a large build volume starting off. This is a very good upgrade to your current repertoire and is an affordable next step. If you liked this video, please feel free to subscribe, and should you wish to support more content like this, you can do so by visiting my online shop, which is in the description below. For those of you who may not know, I do live streams twice a week on Twitch, so make sure to keep an eye out for those if you're interested. Thank you for watching, and I hope to see you guys soon. Thank you and take care.